So in this video, I will explain T-Latch. So what is T-Latch? So basically, this is one NAND gate. This is another NAND gate. Okay. So this is the two input of NAND gate. Here is the output Q, QR. Now another NAND gate, which will actually the output which will actually the input of this NAND gate, and another NAND gate is here the same. Now this is connected here and this is connected here. So one input is here, one input is here, one input is here, one input is here. So this is the JK. So if it is JK, then how I make T? So T is nothing but if we connected these both, then this is called T. So whatever the in J or K, so both are same. Like if T is equal to 0, then J equal to 0 and K equal to 0. And if K T is equal to 1, then J equal to 1 and K equal to 1. So that if I uh, when T equal to 0, then my what is my output here, here and here. Okay, let's see this output. So if T equal to 0, then here my output is 1, because if we go through the truth table of NAND gate, suppose A and B to input of NAND gate and Y is the output. So 0 0 0 1 1 0 1 1. Four combination would be there. So if 0 0, then what would be the output of NAND gate? So 0 0, this is 1 0 1 1 1 0 1, and this is 0. So now um, so now T equal to 0. So irrespective of other input, my output is 1 always. Here 1 always. So now I need to check other input like this. So other input, why I need to check? Because here the two possible. Just look at this. One input is 1, A is 1, but if suppose B is 0 or 1, then what is the output? If B is 0, then output 1, and B is 1, then output 0. So here the change we can see. So if I assume that my previous output is 0, obviously Q are 1. So this 0 goes to this like this way. So 0 and 1. What would be the output? Obviously 1. And this one goes to here. So 1 1. Just see the truth table here. 0. So it's just like hold the value. So when t equal to 0, then your irrespective of q, whatever the q, q plus would be the q. Like if it is 0, then output q. If 1, then q plus. Next state, in next state, q plus equal to the same bit. So it's hold the value. If suppose it is 1, if t equal to 1, then what happened? If t equal to 1, I can comment that in here, what is my output? Okay. So what I assume, that I assume what the previous, that is 0 here, 1 here. So in 0 goes to here. So 1 is here and 0 is here. So what is my new output? If 0 is 1, then it would be 1. No problem. Here I get 1. Here it is 0. So 0 comes to here. So 0, 0, 1, 1. I have no problem. So here 1 and here 1 goes to this and 1 and 1. Here 1, here 1. So now this bit changed. This bit is 0 and this one goes to like this way. So 0, 1, obviously 1. So it now changes. Now change to 1. Now this one goes to here. Now this one if goes to here, then 1 here. Now it changes to 0. So we see that if my t equal to 1, then if q equal to either 0 or 1, then 0 in next state, 0 should be the like 0 toggle to toggled and it's 1. And if 1, then you can realize that it is 0. So it's basically toggle. So T for toggle. Toggle. So basically, this is like T flip flop, most probably used for counter where T is always 1 and we count like down counter or up counter we make by T counter. Basically, it's JK flip flop. We connect the J and K and there we give the uh, toggle input like 1. Nice. So that's all.